All right, ladies and gentlemen, now off to topic C, which is multiplying algebraic fractions. In order to multiply algebraic fractions, the first step is still the same as when you simplify fractions. So hopefully you know what that step is, and that is to factor if possible, okay? And then once you factor, you can go ahead and cancel values. So when we simplified fractions, there was only one numerator and one denominator. But when we when we multiply fractions, it just means that we have multiple numerators and multiple denominators, but we can still cancel stuff out. It's basically the same thing. All right, so then let's read what this says here. You can only cancel if one is in the numerator and one is in the denominator, okay? You cannot cross cancel. And what that means is basically if you have a term or a factor in the numerator and another same factor in another numerator, you're not allowed to cancel them. One has to be in the numerator, one has to be in the denominator, okay? And then you can only cancel expressions out if they are factors. This is key, just like we talked about before. If they are separated by plus or minus signs, then it is absolutely illegal, okay? So let's look at question number 1. Number 1 is nice because you have no adding or subtracting at all, so you can start to cancel stuff out easily without any problems. So if you guys notice right here, let's look at this 5 first. Do you see this 5 right here? This 5 can cancel out either with the 3 or the 20, but it can't cancel out with a 9 because the 9 is also in the numerator. 5 and 3 don't have anything in common though, so we can't really do any reducing there, but the 5 and the 20 do. The 5 and the 20 are both divisible by 5, right? So that means that this 5 can become a 1 and this 20 can become a 4, okay? And then I'm going to do something similar with the x squared. Now the x squared can cancel out with anything like it in the numerator, in the denominator, because this is in the numerator. It can be in the same fraction too. That's totally fine, okay? So if it's in the same fraction, as long as one's on top and one's on the bottom, no worries at all. So this means I've got x times x on top and x on the bottom. One of the x's will cancel each other out. Sorry about that. I'm not quite sure what happened. And then there'll be an x left over in the numerator because there's more x's on top than there are on the bottom. Okay, so this becomes an x here and this x goes away. All right, next thing I'm going to do is I'm going to look at this 9 right here. This 9 can be reduced with this 3, again, because one's in the numerator and one is in the denominator. So I'm going to see what they're both divisible by. They're both divisible by 3. So this 9 becomes a 3. And this 3 becomes a 1, okay? And then I'm going to look at the next term, which is y squared, okay, the next part of this term. And y squared and y are both divisible by y, so this y squared becomes a y, and this y will cancel out. So then, on top, if you guys notice, I have 1x, 3y all multiplied together, so I'm going to say my final answer on top is 3xy. Okay, and in the denominator, I have a 1 and a 4 left over. Everything else is crossed off. So my final answer is 3xy over 4. And I know it's my final answer because 3xy have nothing in common with 4, so I've simplified as much as possible. Okay, now number 2 gets a little bit trickier. Make sure you're paying close attention to this question. So in number 2, I'm going to look at the numerator first in the left fraction. So the first thing I'm going to do is I'm going to ask myself, is there anything in common in my numerator? Is there a GCF? There is. My GCF is 4 because 4 and 12 are both divisible by 4, but I also have x squared because remember you always look for the lowest exponent that's in common with the two variables. So in my numerator, I'm going to have 4x squared as my GCF. And then I'm going to write down what I get left over. So if I divide this 4x cubed by this 4x squared, I end up getting x. And if I divide the negative 12x squared by 4x squared, I end up getting negative 3. All over x minus 2. Okay? Times, now let's look at this numerator right here. By the way, I said all over x minus 2 because I know there's no GCF in this problem. It's not a difference of perfect squares, and it's not a product of two binomials. So now let's look at the numerator right here, x squared minus 4. There's no GCF, but I know it's a difference of perfect squares. So I'm going to factor it as x plus 2 times x minus 2. All right, and then I'm going to look at the denominator and see if there's a GCF. There is. They're both divisible by 6, so I end up getting 6, and then in parentheses, x plus 2. Okay, everything is factored as far as you can go. Nothing inside of these parentheses can be factored any further. Okay, so now I can go ahead and start canceling things out. So if you guys look right here, I have an x plus 2 here in common with this x plus 2, so they're allowed to go. Okay, I also have an x minus 2 here, and that can cancel out with that x minus 2. All right, I also, if you notice, have a 4 here and a 6 here, which means they're both divisible by 2. So this 4 can become a 2, and this 6 can become a 3, making my final answer 2 x squared times x minus 3 all over. In the denominator, these canceled out completely. All I have left over is a 3. And this 3 and this 3 cannot cancel each other out because this x minus 3 right here is all one factor together. It's a package deal. So is there anything else in common with any of the terms in the numerator and the term in the denominator? There is not. So this is my final answer. Topic D is on dividing algebraic fractions. We're going to skip this section on top right here. We're going to talk about this next time I see you guys in class. So I just want you guys to think about this. Copy, change, flip. You guys do this all the time when you multiply fractions. You know that when you divide fractions, you know that when you take a fraction and you divide it by another fraction, you always multiply by the reciprocal, okay? So for example, whenever you have like 2/3 divided by 1/2, you always do 2/3 multiplied by the reciprocal, which is 2/1. So here's your copy, here's your change, here's your flip, okay? And then afterwards, you just treat it like a regular multiplication problem, all right? So in question number 3, the first thing I'm going to do is I am going to copy the first fraction, which is 10ab over 14a squared. Change the division sign to a multiplication sign, and then I'm going to multiply by the reciprocal. So it's going to be 7ab squared over 25b cubed. Now the nice thing is these are all already factors. I don't have to worry about factoring because it's already all multiplication anyways. So I can go ahead and cancel stuff out. So I know that this 10 and this 25 have something in common. They're both divisible by 5. So this 10 becomes a 2. And this 25 becomes a 5, okay? I also know that this a right here and this a squared right here have an a in common, so this a cancels and this a squared becomes an a, okay? I also know that this 7 and this 14 are both divisible by 7, so this 7 becomes a 1 and this 14 becomes a 2. I also know that this b squared right here and this b cubed have a b squared in common, so I have a b left over. Now, if you notice, I purposely did not cancel everything out because I want you to see what will happen if you don't cancel everything out, okay? So let's see what's left over. I have a 2 left over, I have a b left over, and I have an a left over. So this ends up being 2ab in the numerator, okay? Over, in the denominator, I have a 2 left over, an a left over, a 5 left over, and a b left over. So the 2 times the 5 is 10. So I get 10ab, okay? Now, when you don't completely simplify at first, totally fine. You just have to recognize that this is not your final answer. Understand that you can still simplify it because there's something in common in the numerator and the denominator, okay? So they're both divisible by a, they're both divisible by b, and the 2/10 can reduce to 1/5. So all of this junk right here, when you divide it out, ends up being 1/5 right here. All right. So let's look at question number 4. We're going to do the same type of thing. The first thing you're going to want to do is you are going to want to copy, change, flip. Okay. I'm just going to zoom in on this a little bit so I have a little bit more room to show my workout. So let's look at this question right here. I'm going to say that it's 3a over 6a plus 6b, okay? Change the division sign to multiplication, and then change the numerator to a plus b, right? Because you're doing the reciprocal over 5a squared, all right? Now, 3a, I can't do anything with it yet with regards to factoring because it's a monomial, okay? But the denominator has a GCF, which is 6. Let's do that. So I'm going to factor out an a plus b, okay? Now this numerator is already as factored as possible, so it's a plus b, and the denominator is also as factored as it possibly can be. So let's see what can go. I know that this a plus b goes with this a plus b, okay? And I also know that this a goes with this a squared, and I have an a left over in the denominator, okay? I also know that this 3 and this 6 are both divisible by 3, so I get 1 over 2. So I have a 1 in the numerator, and then I've got a 2, don't forget about this 5, and an a in the denominator, so I get 10a. The hardest part is making sure you don't miss out on things like this 5, because it's really easy to not notice the 5 there and to mess that up, okay? And that's how you divide fractions.